Hello and welcome to the 2025 Coolest Projects Hardware webinar. Today we're going to be using a Raspberry Pi Pico to build a simple project that you could use as the starting point for your own fantastic hardware entry to one of this year's Coolest Projects events. Let's have a look at what we're going to make.
Okay, so here's a simple version of the game we're going to build today. We have a sequence of LEDs turning on and off one after another, going round and round in a circle. The idea is that the player has to press this green button to stop the sequence when the green LED is illuminated. Every time they get it right, the sequence will speed up. Let's see how I do. Not doing too badly so far, but as you can see, every time I get it right, the LEDs get faster and faster. And this game is powered by a Raspberry Pi Pico. I'm to concentrate now because the game is getting fast. Oh, I couldn't do it. It got too fast for me. Anyway, that's our simple game, and that's what we're going to be building today. Here's another version built onto a breadboard. This time we've also added a buzzer in for some sound effects. Let's see how I get on. Oh well, not too good on this version. Let's hope I do better in the version we're going to build today.
So that's what we're going to be building. But before we start, let's just have a quick recap of Coolest Projects. What is Coolest Projects? Well, it's a showcase for young people who've made amazing things with technology. It's open to anyone up to the age of 18, and you can either enter our amazing online showcase, or if there's an in-person event near you, bring it along to one of those. Registration for most of these events is open now. How does it work? It's simple. If you've made something cool with technology, either by yourself or in a team of up to 5, you can enter it into one of our categories. The categories are Scratch, Web, Games, Mobile Apps, Advanced Programming, and, new for 2025, our AI category. The final category, and that's the one we're going to be looking at today, is Hardware. And projects are welcome at all levels. They don't even have to be finished to submit them to Coolest Projects. If you've made something and you think it's cool, then you can enter it to Coolest Projects. Here's some dates of some of the events. The online showcase is open right now, and you can register your projects right up until the 28th of May. Coolest Projects Ireland is taking place on Saturday, the 1st of March. Coolest Projects USA is going to be on Saturday, the 5th of April. And Coolest Projects Belgium on Saturday, the 26th of April. If you're in the UK, Coolest Projects is returning to Bradford in 2025 on Saturday, the 17th of May. And there are other events planned for other countries around the world in 2025, so keep your eyes open on our website. If you want inspiration, why not check out the online showcase of some of last year's amazing projects? Just go to coolestprojects.org. And if you want help with your ideas, the best place to go is the project's website on raspberrypi.org. There's even a specific set of projects all to do with hardware and physical computing that we're going to be looking at today. Okay, so now we're all excited for Coolest Projects. Let's start our build. If you remember, earlier I mentioned that we'd be using a Raspberry Pi Pico as the microcontroller at the heart of our project. You can get different types of Pico. There are plain Picos, there are Pico H's, which have the headers, and those are the pins that you connect wires to, already soldered on. And there are W models, which have a built-in Wi-Fi capability. And the latest, greatest Pico is the Pico 2. All of these Picos will work perfectly in the project we're going to be building today. What makes the Pico so cool is all the multifunction pins it has. These can be used for a variety of different tasks. If you want to find out which pins are which and what their capabilities are, you can check out the pinout diagram shown here. The best place for getting started with the Raspberry Pi Pico is to have a look at this project on our website. Not only does it cover setting up the hardware, but it also covers setting up your development environment. That's the software you'll be using to program your Pico and download your code onto the microcontroller itself. We recommend, and we're going to be using today, some software called Thonny. So have a look at this guide because it shows you how to set that up and install one of the libraries we're going to be using as part of our build today. All the circuits and all the MicroPython programs used in this webinar are available at rpf.io/cphw25. Great, so now let's get started with our real Pico.
Here's a real Raspberry Pi Pico. One of the great things about Raspberry Pi Picos is they're quite small, which means it's easy to fit them into lots of different designs. However, today, to make it easy to see what I'm going to be connecting, I'm going to use a really big Raspberry Pi Pico. This is actually just a regular size Pico attached to a breakout board that makes the pins much easier to connect to. Just like the real Raspberry Pi Pico, it has labels on the underside so that we know what all the pins are and also what they do.
Now we've taken a look at our real hardware, let's get started with our first circuit. Our finished game is going to use several LEDs, but to start with, let's just get one LED working. Here's a very simple circuit. We've got a Raspberry Pi Pico, a resistor, and an LED all connected together. The important thing to note is that the LED has two legs, one of which is longer than the other. That long leg, the anode, needs to be connected to the positive side of our circuit, while the other leg, the cathode, is connected to a ground pin. We use a resistor with LEDs to limit the amount of current that can flow to them to stop them from being damaged. It doesn't really matter what value of resistance you use. Anything from about 100 to 300 ohms should be fine. Let's have a look at this with our real hardware.
To go with my really big Pico, I've also got some quite chunky components, some big resistors and some nice big LEDs. One thing to remember about the LED is that it has two pins, two legs, one of which is longer than the other. The long leg is called the anode, and we need to make sure we connect it the right way round in our circuit. So remember, in our circuit we're connecting the first LED to pin 16, which is this one at the bottom. Now, if you're wondering why I'm connecting it on the left hand side, whereas on the circuit diagram it was on the right, don't forget we flipped the Pico over so we can see the pin labels. Next, we need to add in the resistor. And then, to the other end of the resistor, we'll add another alligator lead. And then finally, connect that to the long leg of the LED. Then the last part of our connection is to use a ground pin. I'm going to use this one, which is the one we showed on the circuit diagram, and connect that to the other leg of the LED.
Now that we've built our circuit, we need to write some MicroPython in order to make the LED turn on. As I mentioned earlier, we're going to be using the Thonny editor to write our programs and download them onto the Raspberry Pi Pico. You can find instructions about how to use Thonny and the Pico Zero library that we're going to be using, all in the How to Get Started with Raspberry Pi Pico project that I showed you earlier on in this webinar. Let's look at how to use Pico Zero with an LED. First of all, we import the LED object from the Pico Zero library. Then we set up an LED, I'm going to call it L1, that's connected to pin 16. That's the pin we connected our LED to in the circuit. Then, to check it works, I'm just going to make the LED start flashing using the blink command. If I run the program now by clicking the green button, we should see the LED start to light up. Now we know how to make one LED light up, we can do exactly the same thing with more LEDs. Here's a circuit that has 5 LEDs connected to different GPIO pins of our Raspberry Pi Pico. Let's go to our real circuit and add in one more LED for the time being.
Okay, so I'm just going to stop our program running while we connect in the next LED. There we go. And now I'm going to add the second LED to GPIO pin 22. It's the same process as before. Add an alligator lead and then add in a resistor. You might be wondering why we use resistors. They're really there to limit the amount of current that flows to an LED. Too much could damage it. You don't need to worry too much about the value of the resistor you use. Anything from about 100 to 300 ohms would be fine. Now we then connect to the long leg of the LED. And then finally we'll add our ground connection. Following the circuit diagram, we use the ground pin here, but any one would do. There we go, we've now got 2 LEDs connected.
Now we've got our circuit with 2 LEDs, we need to update our program to make both of those LEDs blink. This is really pretty simple. We just copy the same couple of lines we used before and change some of the numbers on them. Specifically, we need to give each LED a unique name, in this case L1 and L2, and remember we've connected them to pins 22 and pin 16, so that's what's shown in the lines here. And then we start them both blinking. If we run our program again, we should hopefully see that our circuit works and both LEDs flash together.
So I'm going to press the green play button and we can see that both LEDs are now flashing together. Now I'm going to stop the program and connect up the rest of the LEDs. There we go, all LEDs connected.
So now that we've got all of our LEDs connected, we'll need to modify our Python program so that it can control all of those new LEDs. Now, we could just simply duplicate the lines we had before for our 2 LEDs, but remember we're trying to build a game here that rather than turning all the LEDs on together, is going to turn them on in a sequence. So let's try and build that into our project. One thing we can do is to use a Python list. This will make it much easier to turn on the LEDs in a sequence. So let's have a look at a program to do that. Right at the top is the familiar line where we import the LED object from the Pico 0 library. But now we're also importing the sleep function from the time library, because that will enable us to control how long the LEDs stay on and off for. Then we have all the LEDs and the pins they're connected to. But the new innovation is to add all of those LEDs into a list called LEDs. Now, here's the main part of our program. It's in a while true loop, which if you're familiar with Scratch is like a forever loop. And then inside that, we have another loop. And this is like a repeat loop in Scratch. What we're saying here is we're going to use a variable I and change that from 0 all the way up to being the length of our LED list, which in this case is 5. By doing it this way, it means if we were to add another LED to our circuit, we wouldn't have to change anything in this loop. We just have to add them to the pieces at the top. So we've got our variable from I that's going to start off at 0 and go up all the way to be 5. So the first thing it will do is it will turn on LED number 0 in our list. Python lists always start at 0. This is the 0th element, the first, the second, the third, the fourth. So it will turn on that LED, and it will also turn off the I-1 LED, which in the case of a Python list, helpfully, will wrap all the way around and be the 5th LED. Then we wait 0.3 of a second and do the whole thing again. Instead, this time we'll have moved on to I being 1. So we'll turn on the second LED and turn off the first LED. And that process continues, well, forever, because it's in a forever loop. Let's run this program and see what it does to our circuit.
Okay, so let's run the program and see what happens. And there we go. All the LEDs are turning on in a sequence. Fantastic.
Now we've got all of our LEDs turning on and off in a sequence, it's time to add the final component to our project, a button. You can see here that we've connected a button to GPIO pin 15, which is in the bottom left-hand corner of the Pico, and a ground pin. Let's do that for real with our real Pico.
So here's a nice big chunky button with some alligator clips on. And I'm going to connect the other end of these alligator clips to the Pico. It doesn't matter which way round we connect the pins on the button. So one is connected to GPIO pin 15 and the other one is connected to any of the ground pins. That's easy to add in. While I'm here, I'm also going to add in a green LED and swap that for one of the red ones. The green LED will be the one that the player has to stop the game on. So I'm going to just swap this LED here for a green one, remembering to connect it the right way round. Great, we're all ready to play.
Now we need to update our program to include code for the button. Let's have a look at a program that's already had that done. As you can see, it's a bit longer than our previous program, but we haven't actually added that much in. Let's go through the new parts of the program. First of all, we've also imported the button object from the Pico 0 library, just like we do with the LEDs. And then after we've set the LEDs and added them to the list, we also say which pin the button is connected to, in this case, pin 15. Then we use two variables that are going to help us keep track of what's happening with our game. The first one is a Boolean variable, we're calling it running, and that will either be true or false, which will tell us whether or not the game is running. Then we have a speed variable. The speed is the time between each LED turning on and off. And remember, as the player progresses through the game, we want that to get faster and faster, so the game becomes more challenging. To start off with, we're going to set the speed to be half a second. When our button's pressed, that's when all the important stuff happens. We need to do a few things. First of all, we need to stop the LEDs for flashing, but also we need to check to see whether the correct LED is on. Remember, in our game, the player has to try and stop the program when the green LED is illuminated. So to do that, we have a function that runs when the button is pressed, and we set that using this line here. And above, here's the function we use. We set running and speed as being global variables, so we can access them inside this function. And then as soon as the button's pressed, we need to change the state of the game. So if the game was running, we stop it. If it wasn't running, we restart it again. Then we're going to make our speed faster. So by multiplying the speed variable by 0.95, we're basically making that number smaller, 95% of its previous value. This next line checks to see whether it was LED number 2, which is our green LED, to see whether that LED is on or not. If it is, we need to make sure we carry on with the game. If it's not, we're going to set the speed back to its starting value of 0.5. And all that will happen when our button's pressed. If we then go down to the main loop of our program, we can see there's only really one change that we've made, and that is to swap out the value we explicitly stated for speed to be the speed variable. Everything else is exactly the same as the previous code. So let's run that program and have a look at it in action with our real circuit.
Okay, so let's run our program and play the game. I'm going to press the green play button in Funny, and there we can see the LEDs are lighting up in a sequence. I'd rearranged them on the table so that they were roughly in the right order to go round in a circle. Now if I pick up the button, I've got to try and press the button when the green LED is illuminated. Let's see how I get on. Managed it that time, and a second time. That's 3 in a row, but it's getting faster now. Failed immediately. But you can see we've very quickly built a very simple game. Remember, to make it easier to see what we were doing, we used the giant Pico, the alligator leads and some big components. But as we showed right at the start, you can build the same kind of game on a breadboard, much smaller. And in fact, the version in a box that we used earlier uses a combination of the two inside, where we have a breadboard and a load of alligator wires too. You can go crazy, use your imagination and build with whatever you have to hand.
Amazing! So now we've successfully finished our simple but really fun game using a Raspberry Pi Pico, LEDs and a button. But let's not stop there. There's plenty more opportunities to carry on being creative with our project. Here are some ideas for customizing your game. Maybe you could change the gameplay itself. Instead of having the LEDs come on in a sequence, they could flash randomly, making it harder for the player to predict when the green LED lights up. Or, like in the game I demonstrated at the start, you could use a buzzer to add sound effects to help the player know what stages of the game they were at. And because we haven't used all the pins on the Raspberry Pi Pico, maybe you could add some more LEDs to make your game even brighter. I can't wait to see what you do with your game. Don't forget to submit your games to Coolest Projects, either the online showcase or one of the face-to-face events in countries around the world. Remember, all the circuits and MicroPython programs used in this webinar are available at the URL shown on the screen right now. And if you have any questions at all about Coolest Projects, hello@coolestprojects.org is the email address to use. There's also lots of information on the Coolest Projects website and the Raspberry Pi website. That's all for today. Thanks for listening, and I can't wait to see what you submit to Coolest Projects. Bye-bye.